We're going to look at solving equations and look at the tools we have to do that. The first thing we can use to solve equations is the addition property of equations, and that says if you have two things that are equal, A and B, then if you add the same thing to both of them, they still have an equality relationship. This also means you can subtract something from both of these, because if we say A minus C and B minus C, what that really means is C is negative, so we're adding a negative. That's just a shorthand way of doing that. So this addition property also allows us to subtract something from both sides of the equation. Now we're going to use this property to eliminate unwanted terms. Remember, terms are things that are added or if they're a negative, we'd say they're subtracted from other things. So if we want to get rid of an entire term, this is the property we're going to use for that. So let's look at this problem. X minus 4 equals negative 11. I want to get x by itself. So A is x minus 4, B is negative 11. So what I'm going to do is I'm going to add 4 to both sides of this. Now why did I choose 4? We'll see in a second. But just, I'm going to give a little proof while I'm doing this. And so again, x minus 4 is A, negative 11 is B. So by plus 4, that's my C value according to that rule there, that addition property of equations. So now what I can do is I can rearrange the parentheses on the left-hand side and put the negative 4 and the positive 4 together in a parenthesis. Again, that's the associative property of addition. Negative 4 and positive 4 make 0. That's because they're inverses of each other. According to the inverse property of addition, you put two inverses together and you get 0, two opposites. And x plus 0 is just x, and again that's the identity property. So if you add 0 to a number, you get just that number. In this case, the number we're getting is the variable x. And so working out the right hand side, negative 11 plus 4, negative 7, so x equals negative 7. Now you can check this answer, and when we say check, what that means is we're going to substitute this value for x, this negative 7, into our original statement. So I'm going to replace x with negative 7. Negative 7 minus 4, is that negative 11? Well, negative 7 minus 4 is negative 11, and negative 11 equals negative 11, so this is a true statement. When I look at your work, I don't typically check your checks. You can do most checks in your head. I don't want to spend a lot of time. There are certain problems in mathematics that you do have to check because you might get answers that are actually false answers. But at this point, if you do all the work correctly, you should get an answer that works. And I don't want people to make an error while they're checking and think that their original work is incorrect. So I'm not going to make a big deal about checking, but that's how you do it. You substitute the value in for the letter and then verify that the statement is true. Alright, so the work I showed here is a lot more work than we would normally write. So let me show you this work again, and I want to compare it to the type of work I would normally write for this problem. So like I just said, I added 4 to both sides, I regrouped. Well, to handle both of those items, I would come over and I would just add 4 directly underneath my negative 4, because I know those two are going to be opposites and they're going to cancel each other out. So in this original description, I said, okay, that gave me 0. Well, x plus 0 is just x, so x equals negative 7. So if I look at this one, I could write this as x plus 0, but since I know negative 4 and positive 4 are going to cancel out, usually I just write that as x. And that's all the work I really need to show. I don't need to show all these lines like I did on the left-hand side. You can do it just like I did on the right-hand side. Let's say I'm dealing with fractions. Same process. I want to get rid of that 2/3, that term. So I'm going to do the opposite. The opposite of positive 2/3 is negative 2/3. And then, 3/5 minus 2/3, same way I always have to deal with subtracting fractions. I need to find a common denominator. In this case, that's going to be 15. So I need to multiply the top one by 3 over 3, and the second equation, or second fraction, by 5 over 5. So multiplying across, 9 over 15, multiplying across, negative 10 over 15, and then combine the numerators. So 9 minus 10, y equals, you can say, again, y plus 0, but we usually just say y. Y equals negative 1 over 15. What if we have decimals? Same thing. And again, notice my Y, or my letter, my A in this case, is on the right-hand side. That's where your focus needs to be. I need to be with the letter. So see how I have that negative 3.8 term? I need to get rid of that term, and so I'm going to get rid of it by adding the opposite. So I'm going to add a positive 3.8. Those will cancel out. I'm going to add 3.8 to the other side, throw that in my calculator or do it by hand, and I'll get 2.84. So that's the addition property. When you want to get rid of an entire term, that's the property you're going to use. And you're going to add the opposite. So if it's positive, you're in effect going to subtract. If it's negative, you're going to add to get rid of it. The second tool we have is the multiplication property of equations. And what that says is if you have two things that are equal, then if you multiply both of them by the same thing, then you still have an equality statement. There is a restriction on this though, and that is you can't multiply both sides by 0. The reason why is if you multiply both sides by 0, you'll get 0 equals 0. But since that's true no matter if A and B are the same or if they're different, then that doesn't really prove anything. So you can't multiply both sides by 0. This property also allows you to divide both sides by a letter. The reason why that's allowed under this rule is because remember when we say A divided by C, what we really mean is A times the reciprocal of C. So when we're talking about dividing by a letter, it's really multiplying by the reciprocal. It's just more convenient a lot of times to talk about dividing. And again, since you can't divide by 0, C still can't be 0 in this case. We're going to use this property to get rid of the unwanted coefficients. So if you want to get rid of a whole term, you do that by adding or subtracting. If you want to get rid of just the number attached to the letter, the multiplier, then you're going to use this property, and usually we're going to divide. And I think most of the examples we're going to look at, we're going to be doing division. So let's say I'm looking at this property, and again, this first example, I'm going to go through a proof of why this works, and then we'll look at just more typical uses of it. So I want to multiply both sides of the equation by 1/3. And again, the reason why I'm allowed to do that is because of this multiplication property. As long as I multiply both sides by the same thing, then it's legal. And I'm going to drop the parentheses because, again, the associative property, I can associate them however I want, which means I can disassociate them if I want. So I can lose the parentheses on the first two, and then I can flip the place of the x and the 1/3. And that's, again, the commutative property of multiplication. Says you can multiply in any order you want, so I can move that x to the back so that I get my numbers multiplied. Now, because I'm going to multiply a whole number on both left and right hand sides, I'm going to multiply an integer by a fraction, maybe I might want to write those integers as fractions. So 3 is the same as 3 over 1, negative 13 is the same as negative 13 over 1. And then I'm going to multiply those together. Well, if you take 3 over 1 times 1 over 3, you're going to get 3 over 3. Or, in other words, 1. And then the other side, you're going to get negative 13 over 3. That's because 3 over 1 is the reciprocal of 1 over 3, or the multiplicative inverse. So according to the multiplicative inverse, if you multiply it by its reciprocal, you'll get 1. And then 1 times x is just x. And again, that's the identity property of multiplication. So 1 is the multiplicative identity. So a lot of times we won't bother writing 1x, we'll just say x, because 1 times x is x. So let's say I look at this problem. I want to get y. I have negative y right now. So my coefficient in this case is actually a negative 1. To get rid of that negative 1, I'm going to divide both sides by that coefficient, that negative 1. And then on the left-hand side, I'm going to get 8 divided by negative 1, negative 8. On the right-hand side, negative 1 divided by negative 1 is positive 1y, which is just y. The same thing if I have decimals. If I have 2.5x equals 0.81, I want to get x by itself, so I want to get rid of that coefficient of 2.5. I'm going to divide both sides by 2.5. Again, I'm always looking at the variable. I start with whether it's on the left or right-hand side, and I'm going to divide both sides by its coefficient when that's what I want to get rid of. And then throw that in your calculator, get 0.324. What if there's a fraction? Let's say I'm looking at this problem. Negative 2a divided by 3 equals 14. What's my coefficient? If you're thinking it's negative 2, it's actually negative 2/3. This is negative 2 divided by 3. So negative 2/3 a equals 14. So whether they write it as in the first example, negative 2 over 3, or they write it in the second one, the coefficient in both cases is actually negative 2/3. So if you look at these other two examples, I had a negative 1 coefficient on my y. I divided both sides by negative 1. I had a 2.5 coefficient on my x. I divided both sides by 2.5. I have a negative 2/3 coefficient on my a. I want to divide both sides by negative 2/3. Negative 2/3 divided by negative 2/3, anytime you divide a number by itself, you get 1. Now, because I'm dividing by a fraction, reminder that you don't divide fractions, you multiply by the reciprocal. So some people wouldn't have divided both sides by negative 2/3, instead they would have multiplied both sides by it has to be the same sign. It has to be multiply both sides by a negative 3/2 on both sides. And that would have gotten rid of the negative 2/3. But you can do it this way, and just remind yourself, when I actually do this division, I have to change it to a multiplying by the reciprocal of 2/3, so negative 3/2. And again, anytime you take an integer times a fraction, usually you want to write that integer as a fraction itself, multiply top times top, bottom times bottom. So 14 times negative 3, negative 42 over 2, and 42 divided by 2 is 21, so negative 21 is our answer. So those are the two properties we can use, and we will talk about in a future video combining the two into more complicated questions. And which will we do first? What do we have to get rid of, terms first, or do we have to get rid of coefficients first? And what we'll see is we'll want to get rid of constants, terms first, and then get rid of coefficients. But that's